Okay friends, today we will learn mathematics of valuation. In mathematics of valuation, basically as far as IBBI syllabus is concerned, basic thing is construction and use of valuation tables. But as you know, today we do not need valuation tables because many softwares are available just like Excel. You can use directly Excel. In Excel all the required formulas have been inbuilt and you can use them easily without any difficulty. So we will be dealing with all the formulas which you need in valuation, and we will try to drive them and to do all the formulas in Excel form also, so that you are able to solve any case study during your examination, as well as these things will be very much useful for your day-to-day work. First thing you need to learn is annuity. Annuity, it is an annual income. An annuity is a contract for income payable at regular intervals and at specified amounts. An annuity is a contract between you and financial institution. You make a lump sum payment or a series of payments, and in return, the financial institution agrees to make a periodic payments to you, either immediately or at some future date. So, the types of annuity, there are two types of annuity. One is ordinary annuity, and other one is annuity due. In ordinary annuity, payments are made at the end of each period. For example, bonds generally pay interest at the end of every 6 months. In annuity due, with annuity due, by contrast, payment come at the beginning of each period. So see here, payment at the end of each period in ordinary annuity, and in annuity due, payments come at the beginning of each period. Rents which landlords typically require at the beginning of each month is a common example. So now we will learn the concept of capitalization. It can be explained by simple illustration. Suppose there are two friends, A and B. The property owned by A gives him net annual rent of rupees 10,000. B has no real estate, but he has cash in hand and he intends to deposit a certain portion of the cash amount at 5% interest rate of interest in a bank, so that he receives a net income of 10,000 in the form of interest on his capital. What amount should he deposit in the bank? See, if we compare both the investment, the friend A, he is having a property from which he is getting an a rent of 10,000, and B does not have any real estate with, but he has certain cash available with him, and he wants to have rupees 10,000 as interest, and the rate of interest the bank is offering is 5% per annum. So how much amount he should deposit in the bank so that he is able to get 10,000? So net income, or we can say net interest, is 10,000, rate of interest is 5%. Now this 5% means, what does this mean? It means for earning rupees 5, he has to deposit rupees 100 in the bank. And if you apply unitary method, for earning rupees 1, he has to deposit 100 upon 5. Means this much amount he has to deposit in the bank to get rupees 1. So for earning 10,000, he has to deposit 100 upon 5 into 10,000. This 100 upon 5, we can say that It is 5% basically. So we can write it as 10,000 upon 5%. Means he should deposit a amount of 2 lakh in the bank so that he is able to earn 10,000 as interest per annum from the bank. Now see here, what is this 10,000? This 10,000 is net income. This 5% is rate of interest. So this 2 lakh, this amount is, if you have to calculate the value of A's property, which is giving him 10,000, which is the same as the B, the amount of interest B is getting, that is 10,000. So if you compare both of them, so we may say that the value of the property of A is 2 lakh. This is capitalization basically comparing both the investments. So if you see this, 2 lakh is capital. This 2 lakh is called capitalized value of the property of A. And if you see this 10,000 is net income and 5% is rate of interest. So capitalized value, this will be equals to 10,000 means net income and 5% means rate of interest. So capitalized value is equals to net income upon rate of interest. This is the basic of the capitalization for a layman's, in layman's language, to understand it better. So capitalization, it this capitalization is any method used to convert income stream into value. There are two primary income capitalization method: direct capitalization and yield capitalization. So basically this, if we apply this method, net income upon rate of interest, and find the value, that value is called capitalized value, and this procedure is called capitalization. If you take a year's income, say here we are taking 1 year's income as 10,000. So if you use 1 year's income, single year's income, to find the capitalized value of a property, we will call it direct capitalization. Direct capitalization is a method used to convert an estimate of a single year's income expectancy into an indication of value in one direct step. So dividing the income estimate by an appropriate rate. So see here, net income, dividing the net income with appropriate rate of interest will give you, directly give you, capitalized value of the property. So next thing is, what is capitalization rate basically? Capitalization rate is any rate used to convert an estimate of future income into an estimate of market value. So if from this formula you can say, if you want to find rate of interest, so it will be equals to net income divided by capitalized value. So capitalization rate will be net operating income divided by current market value or capitalized value. So what is this net operating income? Net operating income, this is the annual income generated by the property after deducting all the operating expenses, but before deducting taxes and financing costs. So current market value, what is current market value? This is the current value of the property in the market. So direct capitalization, we have already discussed that it is the method in which a single year's income expectancy is converted into capitalized value of the property in a single step. Then yield capitalization, it is a capitalization method used to convert future benefits into present value by discounting each future benefits at an appropriate yield rate. See here, each future benefit at an appropriate yield rate. So basically, in case of yield capitalization, we will be using income from a number of years, not from a single year. Here it will be 1, 2, 3, or it may be more than 3, 4, 5, or up to 50 years, or 10 years, or 15 years, whatever. It is more than 1 year. If you use the income for more than 2 years, or sorry, more than 1 years, for converting it into capitalization value, capitalized value. So that method is called yield capitalization. There are two uh, methods generally. One is discount cash flow method, and other one, this discount cash flow method is basically used to find the viability of a project. So let us suppose there are two projects A and B, and the project which will give you higher net present value will be more viable. So we will discuss this in income approach method, what is discount cash flow method, and another method is internal rate of return method. In internal rate of return is, in this method we find a certain percentage, means you can find out at what percent the project will not earn profit, or it may not face any loss. Net present value means it will be having net present value equals to 0. That is called internal rate of return method. So now we will discuss different formulas which you will be using in IBBI examination as well as during your day-to-day work. First thing, you might have done this formula, compound interest formula. You have been using these formulas in metric or in even in the middle classes. So that formula in compound interest, the interest is paid interest on interest basically. So let us suppose we take R is equals to interest per annum on rupees 1. Present value, we will name principal amount as present value. Let us suppose present value equals to rupees 1. Rate of interest is R. Let us suppose time period is 1 year. So if you use simple interest formula, it is equals to principal amount multiplied by rate of interest multiplied by time. So we can say it is interest is equals to PV into R into T. PV is 1, R is R, rate of interest, and T time period is 1 year. So in a single year, the interest earned will be equals to R, that will be equals to rate of interest. So if you deposit rupees 1 today, after 1 year, you will get an amount 1 rupees which you have deposited plus R, the interest you have earned, means 1 plus R at the end of first year. So the total amount after 1 year will be 1 plus R. If now in the second year, what will happen? The interest will be on C. Now at the start end of second year, what will happen? You will have this much amount in the bank, 1 plus R. Okay, and then in interest which will be paid on one this amount 1 plus R, which was at the start of the second year. So this is the principal amount 1 plus R plus interest, that will be 1 plus R into R. So if you open this R plus R square, so it will be 1 plus R plus R plus R square, 1 plus 2R plus R square. So you can write it as 1 plus R square. So we can write it as 1 into 1 plus R square. So at the end of second year, you will be having an amount equals to 1 into 1 plus R square. Similarly, at the end of third year, you will be having an amount of 1 into 1 plus R cube. Similarly, at the end of nth year, you will be having an amount of 1 into 1 plus R raised to power n. So this amount at the end of nth year, we will call it as future value FV. So you can simply write it future value equals to 1 plus R raised to power n, or we can write it as 1 into 1 plus R raised to power n. So this is the formula for future value. Future value is equals to 1 into 1 plus R raised to power n. This is the basic of all the formulas which you will be using during your study, especially the formula which is to be used for in income approach method. This is the basic formula. So similarly, the amount of PV So let us suppose instead of rupees 1, if you deposit, let us suppose we deposit rupees PV. So PFV will be equals to PV into 1 plus R raised to power n. So this is a basic formula. FV is equals to PV into 1 plus R raised to power n. So suppose you have find out the value of FV for 1 rupees, then you can use this formula to find the value for 10,000, 10 lakh or whatever value for you want to find out future value. So in this formula here n is number of compounding. Basically it is not number of years, basically it is number of compounding. If number of compounding in this case is 1 per year, so then this will be the formula FV is equals to PV into 1 plus R raised to power n. But if number of compoundings are more than 1, let us suppose M. So this formula will change. It will be PV into 1 plus R raised to power M into N, where M is number of payments per year. This rate of interest, this will be divided by M, and number of compoundings will be M into N. So number of payments per year, and which is M is number of payments per year or number of compoundings per year. So FV is equals to 1 into 1 plus R raised to power N. This is the basic formula, and if the interest is paid half yearly, quarterly, or monthly, or if a number of compoundings are more than one, say M, then this formula will be FV is equals to PV into 1 plus R raised to power M into N, where M is number of payments per year. So we'll be taking an example that will make the things clear. Means the more frequently interest is paid, the greater will be amount earned. Means if number as the M increases, your total amount will increase. See here, let us suppose the present value is 1000, N is 4 years, and R is equals to 0.08. Rate of interest is 8%. We will write it in decimals, that is 0.08. 4 years, and it is, if the compounding is done annually, then the formula will be PV into 1 plus R raised to power n, means 1000 into 1 plus R 0.08 raised to power 4. So future value will be 1360 rupees. Means you have deposited 1000 rupees and you have earned at the end of 4 years 1360 rupees. So it means you have earned an interest of 360 rupees. Now see, if the interest is paid quarterly, sorry, by 6 months, every 6 months, means number of compounding in a year will be equals to 2. M will be equals to 2. So rate of interest will be divided by 2, and n number of years it will be multiplied by 2. So it will be 1000 into 1 plus R 1 plus 0.08 divided by 2 raised to power 2 into 4. So you will get an amount of 1368. Means you have deposited 1000 rupees and have got 1368 rupees, man, an interest of 368 rupees. Similarly, if interest is paid every 3 months, means number of compoundings are 4. So you put all the values. So now you will get an amount of 1372 rupees. Means you will earn an interest of 372 rupees. So see here, as the number of compounding increases, your total amount goes on increasing. So next formula is present value of rupees 1. As you have calculated or learned the formula of FV, see here the formula for FV. It is PV into 1 plus R raised to power n. And if you have to find PV, it means PV will be equals to FV over 1 plus R raised to power n. So, so our PV is equals to FV divided by 1 plus R raised to power n. This 1 plus R raised to power n will be in the denominator. So let us suppose FP is 1. If you are calculating present value of rupees 1, it means future value is equals to 1. So then the formula will be PV is equals to 1 over 1 plus R raised to power n. This PV, this formula is called present value factor. So PV is equals to FV over 1 plus R raised to power n. RP present value factor PV, where FV future value is 1, it will be equals to 1 over 1 plus R raised to power n. So basically we can say that PV is equals to 1 upon FV directly. So PV is equals to 1 upon FV. So we will be taking some examples that will make the things clear. A man purchases a land having an area of 4,800 square meter at rupees 20,000 per square meter. He then subdivides it into plots. The net area after provision for roads and other services is 4032 square meter. If he expects a return of 8% on his investment, and all subplots are likely to be sold in a span of 3 years, at what minimum price should he sell all the plots without any loss? See here, he has purchased a plot of 4,800 square meter at 20,000 per square meter. It means he has made an initial investment of 20,000 into 4,800 rupees 9 crore 60 lakh. Now see, he is likely to be sold likely to sold all the, so it means that he will hold his amount 9 crore 60 lakh for 3 years. So we will first of all find out the future value of this amount 9 crore 60 lakh. So for finding future value, you know formula is 1 plus r raised to power n. R you know is 8% and is 3 years. So if you deposit rupees 1 in the bank, you will get an amount of 1.26 rupees 1.26 after 3 years at a rate of interest of 8%. So instead of rupees 1, if you have deposited rupees 9 crore 60 lakh in the bank, so you will deposit, you will cost of the land instead of rupees 1, it means for 3 years if you have deposited rupees 9 crore 60 lakh, you will get a total amount of 12 crore 9 lakh 60,000, 1.26 into 9 crore 60 lakh. So to will get, you will get an amount of at least this much amount. So by selling 4,003, this is the saleable area. For selling this much area, he should at least get rupees 12 crore 9 lakh 60,000, that he does not meet any loss, without any loss. So we will divide 12 crore 9 lakh 60,000 with 4032. That will be the sale price of subplot. At least he should sell at 30,000 rupees so that he can sell all the plots without any loss. So if you want to use Excel for finding future value, for that in a cell insert equal to FB and bracket, and then you will see the function. This function will be inserted as FV. Here it is rate, NPER, payment, present value, and type. So rate, in all the formulas in Excel, rate is rate of interest. NP is number of years or time period. Payment, if the payment is done annually, if you have doing, if you have are doing some payment, then you have to use this payment. Or PV, this is the principal amount or present value, and type. And in this formula, you are basically depositing present value. You are not making payment every year. So you are basically having rate and PER, PV, and this type. Type is by default it will be 0, or the 0 means payment is to be done at the end of the period, means ordinary annuity. and if you type 1 it means it is annuity due. So in this case we know rate, NPER, PV and type. And if you do not require anything, say as in this case, in this example, PMT is not needed. So you will simply have commas here without anything in place of PMT. So rate of interest is 8% and PER is 3 years, not PMT. So nothing is to be filled in PMT. Present value is 9 crore 60 lakh. Type is by default 0, means payment is to be done at the end of period. So it will show as 8%. You write 8%, comma 3 and PER 3. Then nothing is to be filled in place. So just place a comma here. No value is to be filled here. Then present value is 9 crore 60 lakh and type plus 0. Fill all these values, then press enter. You will get this value directly, 12 crore 9 lakh 32,000, approximately the same value which you have got here. Similarly, you can use present value factor. How it will be used? First we will calculate one example manually and then you will do it with Excel. Let us suppose an investor has a right to receive rupees 25 lakh from a property after a period of 9 years. Assuming the rate of interest as 8%, find the rate at which investor will be ready to relieve his future right over the property. Means he has to receive a sum of rupees 25 lakh after 9 years. And if he wants that instead of getting rupees 25 lakh after 9 years, he wants certain amount as on today instead of rupees 25 lakh, then what amount he should get? Rate of interest is 9%. So it means you have to find the present value of rupees 20 lakh. So you know the present value factor formula for rupees 1 over 1 plus r raised to power n. You put all the, and for present value of rupees 25 lakh, it will be 1 plus r raised to power n into 25 lakh. You put all the values. The answer is 12 lakh 50,622. So 25 lakh divided by 1 plus 0.08. R is 8%, means 0.08. N is 9 years. So this is 12 lakh 50,622. It means if you deposit this amount 12 lakh 50,622 in the bank for 9 years at a rate of interest of 8%, you will get an amount of rupees 25 lakh after 9 years. So now we can use Excel to find the present value of 25 lakh in 9 years at 8%. For factor you have to remember is PV. When you type in a cell equals to PV, you will get this type of formula: PV, rate, NPR, payment, future value, type. Now see here it is future value. What is known to you? Rate is known to you, which is 8%. NPR 9 year. So payment, nothing is to be done. No payment is to be done. Future value you know is 25 lakh here. And type, you type 00 means payment is to be done at the end of the period. By otherwise by default if you do not type anything, by default it will take 0. So you put PV is equals to 8%, comma 9, and PER payment nothing is to be done, so simply a comma, then 25 lakh, then comma 0. So put enter, you will get the same result, 12 lakh 50,622 as in this case. See here. Then next is annuity. The amount of rupees 1 per annum, a cumulative sum of, or we can say, see here in future value, what you have done, you have deposited rupees 1 only once. But here, if instead of depositing rupees 1, if you deposit rupees 1 per year, every year, rupees 1 every year for n number of years, then how much amount will be accumulated? So this is a cumulative sum of rupees 1 deposited per annum for n number of years. So for that, we will be driving a formula. So let us take an example here. Let us suppose here we are depositing the amount at the end of the year. So at the start of our investment, no amount is to be deposited. At the end of first year, 1000 will be deposited. At the second year, 1000 will be deposited. Similarly for third, fourth and fifth year, which means from first year onward, at the end of every year, 1000 rupees has to be deposited. Now see if you how much amount will accumulate if the rate of interest is 5%, say. So this amount is deposited at the end of fifth years. It means there is no time period for any interest. So rate of interest now it is 0.5, it means sorry, 5% means 0.05. So 1000 into 1 plus 0.05, so time period is 0, so n is 0, so you will its amount will remain 1000 as 1000. The amount which was deposited in the fourth year, it will attain an interest for 1 year. So 1 plus 0.05 raised to power 1, 1050 rupees. Similarly, this rupees 1000 will earn an interest for 2 years. You put the value to 1 plus 0.05 raised to power 2. So 1102.5. Similarly, you can do it for this, which will for second year, which will earn an interest for 3 years, and for this first year, which will earn an interest of 4 years. And if you deposit all, if you take sum of all these, you will get a total sum of rupees 5525 at the end of fifth year. So instead of doing calculation every time in this way, we will drive a formula that with the that will give you a multiplier. So you will multiply 1000 with that multiplier that will directly give you this value 5525564, because this procedure is quite lengthy and tedious. So let us suppose we are deposit rupees 0 at the start. At the end of first year, at the end of first year you deposit rupees 1. At the end of second year rupees 1. At the end of third year rupees 1. At the end of fourth year rupees 1, and so on. Means now see how the calculation will work. See, at the end of first year you deposit rupees 1. Now at the end of second year, what will happen? You will again deposit rupees 1, and this rupees 1 will become 1 plus r, as in the case you have done in future value formula. So at the end of third year, what will happen? You will again deposit an amount of 1, and this rupees 1, and then this 1 rupees will become 1 plus r, and this 1 plus r will become 1 plus r square. And at the end of fourth year, you will again deposit rupees 1. This rupees 1 will become 1 plus r, this 1 plus r will become 1 plus r square, then 1 plus r square will become 1 plus r cube. Now see, this is a geometric progression. In geometric progression, this is your first term A, this is your first term, this is rupees 1, and common ratio, see here, 1 plus r square divided by 1 plus r, so common ratio will be 1 plus r. So the sum of a GP, it is equals to S. S is equals to A bracket through C raised to power n minus 1 upon C minus 1, where A is first term, which is rupees 1, C is common ratio, which is 1 plus R, and you put all the values here. 1 in place of a, then 1 plus r common ratio raised to power n minus 1 divided by 1 plus r minus 1. This positive 1 and negative 1 will cancel. So it will be having 1 plus r raised to power n minus 1. Now see this. What is this 1 plus r raised to power n? This is the formula for future value. So this formula for S will be equals to Fv minus 1 upon R. So here Fv is equals to 1 plus R raised to power n. For example, a property owner is able to save rupees 5,000 per year from the net income of his property, and he invests this amount each year to earn an interest at 7%. Find the amount which will be available at the end of 18 years. Means he is depositing rupees 5,000 every year for 18 years at 7% interest. So you know the formula, it is Fv minus 1 upon R means 1 plus R raised to power n minus 1 upon R, n number of years 18, R rate of interest which is 0.07. You put all the values in the formula. So rupees 1 will become rupees 34, and for rupees 5,000 you multiply 34 into 5,000 means you will get 1,70,000. Means if you have been depositing, say, see here, you are depositing 5,000 rupees every year for 18 years, it will be 18 into 5 90,000. You have deposited an amount of 90,000, but you have got an amount of rupees 1,70,000. Means you have earned an interest of 80,000. Similarly, a person takes property on perpetual lease at an annual ground rent of rupees 2,40,000. The property remains unproductive for a period of 5 years. If the lessee wants to dispose of the property after 5 years and if the rate of interest is 6%, find out the minimum premium to be demanded by the lessee to obviate the loss. Means a person has taken a plot on lease, perpetual lease, and he is paying a ground rent of 2,40,000 every year. But the property remains unproductive. It means he is not earning anything from the property for 5 years, and at the same time he has been paying rupees 2,40,000 as rent every year. So now he wants to dispose of this property. Now you have to tell how much amount he should demand so that so as to obviate any loss. So means he is depositing. Let us suppose instead of giving ground rent, he is depositing the this much amount in the bank at 6% rate of interest for 5 years. Then how much amount he will earn at the end of fifth year. So the formula you know, cumulative sum formula, FV minus 1 upon R means 1 plus R raised to power n minus 1 upon R. R is 6% means 1 plus R means 1.06 raised to power n is 5 minus 1 divided by R is 0.06. So rupees 1 will become to 5.64 and rupees 2,40,000 it will become 13,53,600. It means if he get this much amount, he will not earn any loss. If you want to use Excel formula is same as FV. Now here instead of present value, this is payment which you are doing every year. That is in the first case 5,000 rupees for 18 years at 7% interest. So rate of interest is 7%. Number of years is 8. So here you are doing payment. See here, payment 5,000. In this question, you will be using this PMT 5,000. So no present values and type is 0. You put all the values. FV is 7% and PER 18, PMT 5,000. So as nothing is to be filled in PV, just comma and 0. You will get press and the enter, you will get result 1,69,995, approximately 1,70,000, which was same, which is when you have calculated it manually. So now this example is very important, and this will be the base of the next formula. A tenanted house is required to be repaired at a cost of rupees 50,000. The tenant asks the landlord to repair the house investing his fund and agree to pay the amount required for repairs without any obligation after 10 years. What amount will have to be deposited by the tenants yearly in a bank if the prevailing rate of interest was 12% for recurring deposit? Means certain tenants ask their landlord to repair the house by spending an amount of 50,000, and they agree that they will pay this amount of 50,000 after 10 years without any obligation, means without any interest, and prevailing rate of interest is 12%. Then you have to find out how much amount they should deposit in a bank or any financial institution at 12% interest, so that they are able to have rupees 50,000 after 10 years, at the end of 10 years. So you know formula will be same. They will be depositing certain amount. The formula is 1 plus r e to power n minus 1 upon r. Let us suppose they are depositing rupees 1 every year. So if in order to get to rupees 1, let us suppose they are depositing rupees 1. So the rupees 1 will become 17.55. If we deposit rupees 1 at 12% rate of interest for 10 years, by using this formula, we know this rupees 1 will become 17.55. Now, if you apply unitary method here, so to grow 17.55 in 10 years, how much amount is to be deposited? Rupees 1. And if you want to grow rupees 1 instead of 17.55 in 10 years, amount of deposit will be deposited in the bank per annum will be 1 upon 17.55. So this 17.55 is S. So this will be equal to 1 upon S. So for 50,000, accumulation will be 1 upon 17.55 into 50,000 rupees 2849. It means if you deposit rupees 2849 every year for 10 years at 12% rate of interest, this will become 50,000. This amount will become 50,000 at the end of 10 years. So see here, this thing to grow 1 rupees in 10 years amount to be deposited in the bank means how much amount is to be deposited in the bank for getting rupees 1 at the end of certain period, that will be equal to 1 upon s. This 1 upon s, this is called coefficient of sinking fund. So what is sinking fund basically? Let us suppose you have built a house today and you have spent rupees 60 lakh over it. And let us suppose a life of the building is 60 years. And if we assume that the rate will remain constant, rates will remain constant, means after 60 years you will need the same amount of 60 lakh to construct the house. So at the end of 60 years, what you need? You need 60 lakh rupees. How you can get this amount? Means every year you will be depositing certain amount in the bank, so that at the end of 60 years you have rupees 60 lakh with you, with which you can construct a new house. This amount which you deposit every year in the bank, that is called sinking fund. So this sinking fund for rupees 1, it is called sinking fund coefficient. So sinking fund, what is sinking fund? I have explained to you. You know this formula is 1 upon S. Means to get rupees 1 after n number of years, you have to deposit this much amount every year in the bank. That is 1 upon S. So 1 upon S, you know it is FV minus 1 upon R. S is equals to FV minus 1 upon R. So here let us see we are using capital R instead of small r. So because here the value of R, rate of interest, is generally on the lower side, between 3 to 5% generally. Maybe higher in certain cases, but generally we use 3 to 5%. So this R will go in the numerator. The result will be R over 1 plus R a to power n minus 1. That this we will denote it with IC. IC is sinking fund coefficient. This is for rupees 1. If you have to get rupees 1 after certain period of time, you have to deposit this amount every year at R rate of interest. So here R value of R generally is 3 to 5 years percent, 3 to 5%. So let us take an example. The owner of a machine anticipates that he will need to provide a new motor in 10 years time at an estimated cost of rupees 7,000. So if capital can be invested at 8% compound interest, what amount should be invested annually to meet his future estimated cost? Means the person need rupees 7,000 after 10 years. So what he will do? He will do is deposit certain amount in the bank at 8% compound interest, so that he is able to get rupees 7,000 after 10 years. So for 1 rupees, the formula is IC is equals to 1 upon S, or it is equals to 1 upon FV minus 1 upon R, or IC unit is equals to capital R into 1 plus capital R into power n minus 1. So R it is equals to 0.08, 1 plus 0.08 raised to power 10 minus 1, means for rupees 1 you have to deposit this amount 0.0269 every year in the bank. So for getting rupees 7,000, you will multiply it with 7,000, means you will be depositing an amount of rupees 483 in the bank for 10 years, and after 10 years at 8% compound interest you will get an amount of 7,000. So you can use Excel sheet to find the sinking fund. For sinking fund coefficient, or for sinking fund, the shortcut key is equal to PMT. You write this equals to PMT. This function will open up a rate NPR. So here you need future value, because in the future you need rupees 7,000. So there is no present value. So simply two commas here. So fill R rate 8% and PER 10 years. Nothing is to be filled in PV. FV is 7,000. Type, you put all the values here, 8%, 10, space 7,000, 0. Press enter, you will get this result. This is same as 483C. The next is year's purchase. So what is year's purchase? Read the definition. This is the present value of a right to receive rupees 1 at the end of each year for n years at R compound interest. So let us suppose you have rupees 1 for 15 years at present capitalization rate is 6%. If you calculate the value of rupees 1 received for 15 years, the total cumulative sum at 6% compound interest will be 9.72. See here, you deposited at the start, you deposited rupees 1 at the end of the year, first year. This rupees 1, its present value, which you have deposited at the end of, which you will be depositing at the end of first year, its present value, the present value factor, 1 over 1 plus r a to power n, you put all the values, you will get 0.94. The rupees 1 which you have to get after second year, its present value will be By using the formula, it will be 0.89. Similarly, you can find the value for each year. Means you have the right to receive every year rupees 1 at the end of each year for 15 years. For 15 years, at the end of each year, you have the right to receive rupees 1. But if you have to find its present value of all sum of present values of all these rupees 1 at the start, means as on today, you get calculate the present value of all the rupees 1, then get it deposit, it is 9.72. Means the rupees, instead of getting rupees 15, and 15 means at the end of 1 rupees at the end of every year, you if you want to get its present value, means this much amount will present amount of 9.72 will be equals to rupees 15, which you have to get in future at the rate of rupees 1 at the end of each year. So instead of rupees 1, if you are getting rupees 1000, it means present factor will be 9.72, and if you multiply and if you calculate these values 9400, 8900, you get the sum, it is 97,200. Means if you multiply this 10,000 with the present value of rupees 1 as in the first case, 10,000 into 9.72, this will give you the value of for rupees 10,000. So this 9.72, this multiplying factor is basically years purchase. So instead of getting YP in this way, doing calculation in this way, which is very long and tedious procedure, we will find an formula which will directly give you this value 9.72 in a single step. So that formula, there are four types of formulas in years purchase. One is YP single rate, then YP perpetual, then YP reversion to perpetual, and the fourth one is YP dual rate. First is years purchase YP single rate. What is YP single rate? This is the present value of a series of future payments or installment of rupees 1 that are to be invested at fixed compound interest rate over a given period of time. So let us suppose you are getting rupees 1 as rent from a property at the end of each year, and you deposit this amount in the bank, and you have been doing so for n number of years. Then if you are depositing rupees 1 at the end of each year for n years, you will accumulate this much amount. You know the future value formula for cumulative sum of rupees 1, which is FB minus 1 upon R. It is 1 plus R raised to over n minus 1 upon R. So let us suppose this amount is equals to X. Now this is the amount which will be accumulated after n years. And if you want to find its present value, then what you have to do? You have to multiply this amount with the present value factor, which is 1 over 1 plus r raised to power n. So this present value of x discounted at r compound interest means 1 plus r raised to over n minus 1 upon r. To find its present value, you multiply it with 1 over 1 plus r raised to power n. This present value of x, it is called YP. This is called YP. This is years purchase. So if you rearrange this, we will be having 1 plus r a to power n upon r into 1 plus r a to power n. See here, we can write it like this: r in the denominator, and then again 1 upon r into 1 plus r a to power n. So we can write this like this: 1 plus r e to power n divided by r divided by 1 plus r e to power n minus 1 upon r to 1 plus r e to power n. You can write it like this, or this 1 plus r e to power n or 1 plus r e to power n, they will cancel each other. You will be having 1 upon r minus 1 upon r into 1 plus r e to power n. Here you can take this 1 upon r common from these two terms. It will be 1 upon r. Here it will be, you will be left with 1 minus 1 over 1 plus r e to power n. So now what is this 1 over 1 plus r e to power n? This is present value factor. So you can write it as 1 upon r into 1 minus 1 upon r plus 1 plus r e to power n, or you can simply remember it in this term equals to 1 upon r into 1 minus p. This is a way of remembering. So you can remember all the formulas either in the they are either in the form of PV or either they are in the form of FV. So you should remember this YP single rate, this formula. This YP single rate will be used when the number of years time period, here time period is n, if it is less than 50 years, less than or equal to 50 years, you will be using YP single rate. So see here, now if you apply the same formula for this example, here rate of interest is 6%, number of year is 15, you put all the values here, 1 upon 0.06, 6% is 0.06, 1 plus 0.06 and is 15, you will get the same result 9.72, the same factor which you have calculated in this way. So this, in this way you can find the YP, this factor, in a single step. So we will be taking an example. What is the cost today for an investor to purchase an annuity of rupees 50,000 per annum for 5 years, followed by an annuity of 30,000 for 5 years at 9% rate of interest? Means you have to find an amount which you should deposit today so that you are able to get 50,000 per annum for first 5 years, and after that you are able to get rupees 30,000 for the next 5 years, sorry, for the next 3 years, sorry, next 5 years, sorry. Okay, so what we will do, we will find, first we will find, this is basically the amount which is to be deposited. See here in this question, if you deposit rupees 1097,000, what is this 97,200? Means if you deposit this amount 97,200 in the bank, you will be able to get rupees 10,000 every year for 15 years. This is the basic thing. This will be called capitalized value. We, we will do it in next slides. So this 97,200, this is the amount if you deposit in the bank, and the bank at the rate of 6% will give you 10,000 rupees every year. So similarly here you have to deposit, find out how much amount you should deposit in the bank so that you are able to get 50,000 every year. So how you can calculate that? It will be 97,200 divided by 9.72. So if you know this thing, for finding this amount, what you need? You need 11.7, this factor YP. So this is 50,000, you will, instead of 10,000, if it is 50,000 and these two things are known to you, you can find out this amount. So it means you have to find how much amount you should deposit in the bank. So for that you need 9 this YP. Once YP is known to you, you will multiply it with the required amount. You will get the result. See here. For years, so YP you calculate the YP, you put the formula. Formula is 1 over R into 1 minus 1 over 1 plus R raised to power n. R is equals to 0.09 and n is equals to y. You put all the values here. YP is 3.899. It means for rupees 1, you require to deposit rupees 3.889. For 50,000, you need to deposit an amount of 1,94,450. Okay. Now, for the next 5 years, you require 30,000. So again, the same formula you will apply. For rupees 1, you require 3.889, and for 30,000 you require 30,000 to 3.889, 1,60,670. But this amount you require after 5 years. This amount you require after 5 years. So what you can do, you will find its present value. That amount after 5 years, if you have to have deposit of it after 5 years. So if you want to receive this amount today, you will find its present value. So present value, you know, the present value factor is 1 over 1 plus r raised to power n. So instead of depositing 1,60,670, so that you are able to take 30,000 every year, you will need to deposit a sum of rupees 75,835 in the bank. So the total amount 1,94,450 for first 5 years and 75,835 for the next 5 years. So the total amount you should deposit is 2,70,286 in the bank. So you can use Excel sheet for finding the value of YP directly. Why not? You need not to remember this formula at all. Just you should know how to calculate the value. So here you have to find, you know, present value factor. Present value, for present value, you know, you have to write insert this function. It will look like this. Here you know to need to find the rate and to fill NPER, which is 5 years, rate is 9%, PMT. Now here it is PMT. You are making payment every year. Require payment 50,000. You need payment 50,000, no future value. Type is 0. You put all the values 9%, comma 5 into 50,000, comma. So nothing is to be filled in place of FV, comma 0. You will directly get the result, which is 1,94,450. Similarly, you can find the value for the second for 30,000, which will be 1,60,690. You can find repeat the same instead of payment. You can find this value. So you have to find the present value of this 1,60,690. So do you know, for that you have to insert this function PV rate and PER. Now here instead of PMT you will fill the value of FV. Means PV is 9%, 5 amount future value is 1,16,670, comma 0. So here nothing is to be filled in place of PMT. So you will get the result of 75,835. So you add up both of them, you can find the value same result as 2,70,286. Now next is years purchase perpetuity. You know you have derived this formula YP is equal to 1 upon R into 1 minus 1 upon over 1 plus R raised to power n. So now see here in the bracket, something is being subtracted from 1. So as the value of n increases, the value of this term 1 over 1 plus r raised to power n will go on decreasing. See here, let us take for example, we take 1 plus r raised to power n at the rate of 10%. If the value of n is 1, this factor will be 0.9090909. And if you go on increasing, let us suppose value of at the end of any 100 years, 1 over 1 plus r raised to power 100, the value will be 0.00007, which is approximately equal to 0. So if n is very large, 1 plus r raised to power n, 1 over 1 plus r raised to power n, it will be approximately equal to 0. So we can write yp is equals to 1 upon r into 1 minus 0. So it will be yp what 1 upon r. So yp in perpetuity. This is 1 upon r. It is called yp in perpetuity. So yp in perpetuity formula is 1 upon r. So this is simple one. So this formula we will be using when the number of years is greater than or equals to 50. So if n is greater than 50, we will use yp in perpetuity. Let us suppose n is equals to 50, r is equals to 0.1, and n is equals to 50. So if you find yp single rate, see, yp is single rate 1 upon r into 1 minus 1 upon 1 plus r raised to power n. R is 0.10 and n is 50. What it will be 9.91, and yp in perpetuity 1 upon r formula, it is approximately, see, these two values are equal. So if n is greater than equals to 50, yp single rate and yp in perpetuity are approximately equal. So if n is greater than 50, we will use yp in perpetuity. The A is the owner of a freehold interest in a shop yielding a net income of 25,000 per annum. Assuming the 7% compound interest, calculate the capital value of A's interest. So YP in perpetuity. So here, see, no time period is given. When no time period is given, you will assume it to be perpetual. So in that case, you will be applying YP in perpetuity, which is equals to 1 upon R. So YP in perpetuity is 7%, 1 over 1.1 over divided by 0.07. So 14.2686. So capitalized value, it is equals to 25,000 into YP, which is 14.286. So 3,57,000. So same you can apply here in for applying. There is no inbuilt formula basically, but you can use Excel here. The amount is 25,000. Rate of interest is 7%. Just write equals to 25,000 divided by 7%. You will get the result directly, 3,57,000. Next is year's purchase of a reversion to a perpetuity. So for this we will be taking an example that will make the things clear. Let us suppose Mr. X will receive a full rental value of 36,000 per annum after 7 years. So presently she let her house at a rental of 24,000 per annum for 7 years with an interest of 8%. Find the value the interest of Mr. X. See here, presently she is getting Mrs. X is getting 24,000, and she after 7 years he will start getting rupees 36,000. So now if you have to find YP, see here what you can do. For example, for first year 0 to 7 year you are getting an amount of 24,000. So after 7,000 you are getting 36,000 perpetually. So if you have to find YP for this period 0 to 7, you will be applying YP single rate. And if you have to find the value of 36,000, and now suppose, and you know after 7 years he will be getting 36,000 perpetually. Now if you apply YP perpetual, it will be from 0 to perpetual, but you have already calculated for this period 0 to 7 year for this much amount 24,000. So basically for this amount 36,000 you need to calculate for this period from 7th year onward up to perpetual. So it will be equals to YP perpetual minus YP single rate. So YP perpetual, which is from 0 to perpetual, from this you will subtract YP single from 0 to 7. So this procedure is adopted when there is change in interest, change in earning or income after certain period of time. This YP, so YP perpetual minus YP single rate, it will be equals to 1 upon R minus 1 upon R into 1 minus 1 upon R raised to power n. This is YP single rate, this is YP perpetual. This is called YP perpetual reversion to a perpetuity. This is called reversion to a perpetuity. And if you open up this, it will be 1 upon R minus 1 upon R raised to power n. This 1 upon R and 1 upon R will cancel. You will be left with 1 upon R into 1 plus R raised to power n. It will be equal to 1 upon R into PV. So for this period from 7 to perpetually, you will use this formula PV upon R. And for this period from 0 to 7, you will use this formula YP single rate, which is 1 upon R into 1 minus 1 upon 1 plus R raised to power n. So this is basic formula for YP reversion. So if you open up 1 upon R minus 1 upon R into 1 minus minus plus 1 upon 1 plus 1 over 1 plus R raised to power n. This 1 upon R and 1 upon R will cancel each other. So you will be left with 1 upon R into 1 plus R raised to 1 upon 1 over 1 plus R raised to power n. This term is PV. So 1 upon R into PV. So YP reversion will be equal to 1 upon R into 1 upon 1 plus R raised to power n. Or we can write 1 of PV upon R. This is the formula for YP reversion. So we will apply this formula for this 24,000. We will apply YP single rate. You know this formula 1 over R into 1 minus 1 upon R 1 plus R raised to power n. R you know is 0.08, n is 0.7. You put all the values. YP single rate will be 5.20. You multiply it with 24,000, it will be 1,24,800. Then for reversion means for this amount 36,000 after 7 year formula, you can directly apply this formula PV upon R, or you simply apply this formula 1 upon R minus 1 upon R into 1 minus 1 over 1 plus R e to power n, or you can simply apply this formula PV upon R. You will find again from both the formulas you will get the same result, which is 7.29. So here capitalized value will be 7.29 into 36,000 for this period. Formula is P upon R, PV upon R. So the value is 2,62,240. You add both the values. So value in of the interest of Mr. X, Mr. X, 3,87,360. So if you find if you want to find by using Excel sheet, you know for 24,000 YP single rate formula will be PV into rate NPER PMT FV and type. Here you have to fill the value of rate NPER and PMT, no future value, and type. You put all the values 8% rate, 7 years NPER 24,000 PMT. Nothing is to be filled in FV and type by default is 0, or either you can write 0, does not matter. You put all the values, answer will be 1,24,952, as here you have calculated approximately the same value. And then for 36,000, because it will be perpetual, find the value 36,000 with Excel for 7 years. The value will be 21,005. So its capitalized value will be PV upon R. You put all the values. PV upon R is 8%. This is present value. You know the present value 36,000, and PV upon you. PV is 21,600 and R is 8%. So PV upon R will be 21,005.65 divided by 8%. You will get the same result, 2,62,571. You add both of them, so you can directly find with the help of Excel, or you can use this formula to find it manually. And then in the end, last one is YP, years purchase dual rate. So see, let us suppose a person has taken a cinema hall on lease. The lease period is, let us suppose, 30 years, and he is earning an income of, let us suppose, 15 lakh from the cinema every year. Now see, after 30 years, what will happen? Leasehold property will go back to the lessor, and mm, he will not having anything for his income. His income will cease. So in such a cases where the asset is of diminishing type, we use YP dual rate. In YP dual rate, the rate of interest is changed from R to R plus IC, where IC is sinking fund coefficient. So we will assume that the person whose lessee whose lease period will expire after 30 years, he will deposit certain amount in the bank in the form of sinking fund, so that he is having certain amount in the bank, so that he is able to buy a new property, or he can take some property on lease, so that his income start again. So instead of R rate of interest, as in the case of YP perpetual, this R will be replaced with IR plus IC, where IC is, sinking fund coefficient, which is capital R over 1 plus R raised to power n minus 1. So see here, why we have taken this as capital R. So these small r and capital R cannot have the same value. They will be having different value. If they have same value, you will get the same result as in the case of YP single rate. So instead of R, as in the case of perpetuity, we will use R plus IC. Rate of interest will be R plus IC. So let us assume that rate of interest for rupees 1 is R and sinking fund factor is IC. So total capitalization rate will be R plus IC. So let us assume that capitalized value is M. So M, and yearly income. So for finding in yearly net income, but the formula, you multiply capitalized value with capitalization rate. So capitalized value is M, CV equals to 1 M, and capitalization rate is R plus IC. R plus IC. So your yearly income will be M into R plus IC. So another formula, also capitalized value is equals to income into YP, or YP, it is equals to CV over income. CV over income. So YP is equal to CV, capitalized value is M, and income, you know, it is equals to M into R plus IC. You put values, M and N will cancel each other. So YP, this is called YP dual rate. It will be equals to 1 over R plus IC. So YP dual rate is 1 over 1 R plus IC. So see here, you know this R here, this R small r, it is known as remunerative rate. This is known as remunerative rate, and capital R, which is used for funding sinking fund coefficient, it is called accumulative rate. Its value is generally bond value, government bonds, which is approximately 3 to 5%. So this remunerative rate, this is 0.5 to 1.5% higher than the prevailing rate. So here YP dual rate, you know, and YP single rate. This is the difference between YP single rate and dual rate. This YP single rate is 1 upon R plus capital R into 1 plus R a to power n minus 1, and YP single rate is 1 upon R into 1 minus 1 over 1 plus R a to power n, or we can say 1 minus PV simply. So we will take an example, use of a question. In here, see here, if you use, let us suppose R percent rate of interest, R small r and capital R is equals to 5%. If you put the value in this equation, you will get YP dual rate as 4.329, and if you use the same 5% in YP single rate formula, you will again get 4.329. So if R and capital are equal, you will get the same result for YP dual rate and YP single rates. That is why this small r and capital R cannot be equal if you are using YP dual rate, even otherwise. So hence YP dual rate will give different value only if small r is not equal to capital R. Find the capitalized value of an income receivable for 5 years at 20,000 per annum net, assuming rate of return at 7% per annum, and sinking fund rate or accumulative rate of interest is 3%. You know capitalized value is equal to net income into YP for 5 years at 7% and sinking fund 3%. So you know remunerative rate is 7%, accumulative rate is 3%. A YP dual rate we will be applying in this case. So it will be 1 over 1 plus 1 over R plus IC. R plus I, you know, R IC is equals to capital R over 1 plus capital R h over n minus 1. You put all the values here. R is 0.07, capital R is 0.03. Use YP dual, it will be 3.87. So capitalized value will be 20,000 into 3.87, which is 77,400. So similarly, you can find it by using uh, this Excel sheets. So for finding annual sinking fund coefficient, you know the formula is PMT. So here, instead of putting any value, you will be getting calculating PMT or sinking fund coefficient for rupees 1. So here future value, in the case of future value, you will put value FV is equals to 1. Rate you know is 3% and PER is 5. Nothing is to be filled in PV. Future value you know is rupees 1. You will calculate IC or PMT for rupees 1, and type by default is 0. You put this value 3%, comma 5 NPER, then nothing, and PV future value is 1 comma 0. So answer will be 0.19. So PMT is 0.919. R you know is 7%. ICU calculated 0.19. Amount is 20,000. So Rate of interest, you know, it is R plus IC, means 7% and 19%, so 26%. So you calculate the capitalized value simply 20,000 divided by rate of interest. You know, capital value, net income divided by rate of interest, which is 26%. So it will be approximately 26,023, which is 77,000, which you have got in where you have calculated manually. So this is all for mathematics of valuation. Thank you very much. Thanks again.